Hello, good evening, friend. Now let us see the next problem, that is problem number 61. Okay, these are all the problem based on the atomic radii, students, which we have to understand. So this which of the following the ion with the smallest ionic radii, okay, smallest radii. So K plus Ca2 plus Ti3 plus and Ti4 plus is there. Student, when you are going to solve this kind of problem, so what are the there, that is K plus is there, student, K plus, then Ca2 plus is there, and Ti3 plus is there, and Ti4 plus is there, so student, when you are moving left to right, if you see, if you are moving left to right, student, what is happening, that you have to keep in mind. So left to right radii decreases, left to right, in period what will happening, student, left to right in period radii decreases, okay, radii decreases, right, student. So that is potassium is there, then calcium, then scandium, and then titanium, okay. So left to right is there, right. So this is the titanium is very small size. So this was the case number 1. Case number 2, greater the positive charge, greater the positive charge on atom, okay, atom, smaller the radii, smaller the radii. So dear student, if you see, that is titanium is there, titanium 3 plus, and titanium what is there, student, 4 plus. So titanium 3 plus is there and titanium 4 plus. So titanium 4 will be, that is smallest radii, smallest radii, this is. So correct option will be titanium 4 plus, option number 4, okay. So next one is, which of the following isoelectronic species is smallest, okay. So that also the good question, student. For isoelectronic species, student, we go for the we check, that is, which is having the more number of proton, okay, more number of proton. So if you see, student, proton how much are there, 8, and proton is 9, okay, here proton 10, and here proton 11. So 11 positive charges, attracting 10 electron, 10 to 10, okay, 9 is 10, and 8 proton attracting 10. So which will attract, in which more attraction will be there, student? Attraction in the option number 4 will be more, where 11 positive charge are attracting the 10 negative electron. Now let us move the problem number 61, student. What is the problem number 61? If you check out, student, the order of magnitude of ionic radii, okay. So what are the order there is N3 minus, O2 minus, and F minus is, okay, N3 minus, okay, what are there, N3 minus, O2 minus, and F minus, right, student. So these things you keep in mind. So greater, these all are isoelectronic, student, greater the negative charge, okay. Let me write somewhere, student, for 63 I am writing somewhere, okay, so that you will be able to understand. So if isoelectronic is there, for isoelectronic, student, we keep in mind isoelectronic species, that is greater the negative charge, student, greater the negative charge, okay, greater the negative charge, more will be radii, okay, student, more will be radii. So you see, which is having the greater negative charge, student, N3 minus is more negative charge, then O2, then F. So N3 will be largest side, then O2, then then this is also wrong, N3, O2, and F minus. Option number 1 is correct, student. Option number 1 is the correct option, student. More 3 negative, 2 negative, 1 negative. Now let us move problem number 64, student. What is there? Which of the following is the correct order of size of the given species? So I minus, I plus is there. So student, positive charge is small size, right? Negative charge, what is, student, negative charge? Large size, okay, large size. So between that atom will be there. So which is positive charge is smallest one, this is the smallest one, then this is the negative charge, but this is the negative charge will be the largest one. So this is wrong. Which is negative charge? This is student. This is will be the correct option, student. Negative charge, then no charge, then positive charge. So I minus is largest side, then I positive. So correct option is option number 4. Last question 65. What will be the screening constant of the sodium atom? Student, this is quite good question for the NEET and JEE student. You have to keep very good concept on the question number 65. Okay, let us try to solve this question number 65, student. Okay. Okay, so 65 they are saying, student, we have to calculate the screening effect, screening constant. Okay, screening constant for what, student? Screening constant for sodium atom. Okay, sodium atom. Dear student, that you have to keep in mind, if n minus 2 cell is there, n minus 2 cell, for n minus 2 cell electron, it is it is the, that is n into n into 1. Okay, screening effect is 1. N is the number of electron, n electron, and that is n minus 1 cell electron is there, so this is Ne into 0.85, right, student? So this is there, student. And for other, when you are going to calculate, student, so let us try to solve it out. Last cell electron, that is zero shielding effect. So for last cell, zero shielding effect, no effect is there, student. So if you see the sodium atom is there, sodium 11. So what is configuration? 1s2, 2s2, 2p6 and 3s1. So this is having 0 because last cell will not have the screening. This cell is what, student? N minus 2. This orbit is n minus 1 and this is, that is n. Okay, so if n is 3, so n minus 1 is 2 and then n minus 2 equal to 1. So here that is how many electron? 2 electron, and here is 8 electron is there. So that is sigma equal to what will be there, student? So 2 electron into 1 plus 8 electron into what is the value? I told you 0.85. Just simplify 2 plus, if you are adding it out, it is coming 6.80. If you add out 8 point, it is coming 80. Sigma screening effect is 8.80. So now let us come to the option, student. Check out which is correct. 8.8, that is option number 3 is correct, student, for 65. Let us move the next question, student. Question number 66. Screening effect is not observed in. Okay, so they all helium, if you see, student, 1s2. Okay, and beryllium you see, student, beryllium, so 1s2 and comma 2s2. Next one is hydrogen is there, student. So that is, if you talk about the hydrogen, this is also 1s1. So this all is having the s orbital, student. Okay, so that is, this 1s do not cause screening effect, student. It is hardly 0.3 is there, very less. So all of these screening effect is not observed in all of these. Next question is there, student. Question number, this is question number 67. Let us try to solve it out. Question number 60. When neutral atom is converted to anion, anion means more electron means the less attractive force, so size will be increasing. So option number 3 is correct, student. Size will increase. Anion, student, anion, more size. Anion means more size. Okay, and cation, student, cation, this is the less size. Cation is less size. Next 68. If you are going for the question number 68, what is the question number 68? The order of screening effect of the electron sp-df orbital of a given cell of an atom is its outer cell is what? sp-df, student. More is the s screening, then p screening, then d, then f. Least screening is there in the f orbital, d orbital. Most screening is there s orbital and p orbital. 69 number question. Which one of the following has largest radius? Largest radius means more the negative. Okay, more the negative charge Okay, more the negative charge, larger the size, So see, which is having the more negative charge, oxygen. So correct option will be O2 minus. So 69, option number 3 is correct, student. Next, question number 17. Atomic radii of fluorine atom and neon atom is in angstrom unit are respectively. This you have to keep in mind and memorize, student. That is for fluorine atom, that is 0.78762 is, and that is for neon is 1.68. Why more, student? This is having the van der Waal radii. Okay, because this is the gaseous atom, gaseous volume. So van der Waal radii is always larger than the, that is the covalent or ionic radii. Okay, so or atomic radii. So correct option is option number 1, student. Next one, atomic radius is measured by X-ray diffraction technique, student. With the help of X-ray diffraction technique, we measure the atomic radii. Van der Waal radii is used for, if you talk about van der Waal radii, used for, student, that is molecular substance in gaseous state, not gaseous, student, solid state. Molecular substance in liquid state, not solid liquid state. Molecular substance in solid state. That is correct option is option number 3. That is van der Waal radii is used for the molecular radii, calculation of molecular radii, but the case is should be in the solid state. Okay, molecular substance should be in the solid state. Next one, separation of lanthanoid from the mixture is not easy because of what, student? Consequence of lanthanoid contraction. Due to lanthanoid contraction, student, they are having the almost equal size. That is why separation of lanthanoid from their mixture not easy because of lanthanoid contraction. Next one, student, if the atomic radii of fluorine is, how much is there, student? Fluorine, they are saying that is X angstrom. Then atomic radii of neon. So neon will be, that is what, student? More than X angstrom. So more than X. So you see, student, option number 2 is correct, student. Option number 2 is correct. Means that is radii of the neon is greater than, fluorine. Because of why, student? Because of neon is having van der Waal radii, VR. Next, 75 number. If an element Xe assumed to have 3 type of radii, then their order is, order means what, student? If you want to go for order, so van der Waal radii is, VVA, van der Waal radii is highest. Okay, then which will come, student? That is largest is van der Waal radii. Then will come covalent. Okay, covalent. Then it will come ionic. So now let us take with the option, student. What could be the option for the question number 75? You see, student, van der Waal is there. Then it will come, student, covalent. Covalent, van der Waal, covalent, and crystal radii. That is option number 4 is correct, student. Van der Waal radii, then covalent radii, then ionic radii. Ionic radii, or you can say crystal radii. So question number 75, option number 4. Student, in the book the option is wrongly given. You have to check it out. Okay. Next question is, what is there, student? Next question you see, that is question number 76. Crystal radius of lithium is 123 picometer. Then covalent radius of Li will be, okay. So student, that is covalent radius is larger than, okay, crystal radius. So if you check out, student, 76, it should be 76. Crystal radius of Li is this much. Then covalent radius will be less, student. This is, I think, this problem is correct only. Whatever we wrote here, this is not the correct answer, student. The order will be this one. Option number 2 is correct, student. Please recorrect yourself. That is, I again writing VW or van der Waal radii. Then that is crystal radii. This is crystal radii. Then it will come, that is covalent. Okay, student. So means covalent have the smallest type of radii. So if you take this option, student, so that is the covalent will have the lesser radii than 123 picometer. So option number 2 is correct, student. Okay, somewhere we have to consider in different ways, student. O2 and Si are isoelectronic if the ionic radius of O2 is 1 angstrom. Then ionic radius of Si4 will be, student. Okay, let us try to calculate, student. Ionic radii O2 minus, how to calculate, student? Z by E. So Z by Z value for oxygen atomic number 8, electron is 10. So it is coming 0.8. For if you are coming for the Si4 plus, Si4 plus, so Si4 plus, that is 14 upon how many electron? 10. So it is coming 1.4. Okay, so student, they are saying that is 0.8 becoming 0.8 is equal to 1. So 0.8 equal to 1, so 1.4 equal to, this will come, student, this is the answer will come 77, option number 1. Next one question, student. Question number 78. Which of the following pair of ions have the same electronic configuration? Same electronic configuration means same atomic number. Same atomic number. Whoever is having same atomic number should have the same electronic configuration. Same electronic configuration. Right, student. Now see. Fe3 plus is having, that is 23. Mn2 plus 25 minus 2, that is 23. This is having the same number of electron. So it is having the, our answer will be this. Chromium is how much? That is, chromium is 24 minus 3, that is 21. And this is Fe3 plus, that is 26 minus 3, 23. So this is not correct. Fe3 plus, that is 23. CO3 plus, that is 25. These all are wrong, student. Correct option is option number 2. In a period, atoms with smaller radii is, which have the smaller radii? Halogen is having the smallest radii, student. 80 number. As number of proton in the nucleus increases, atomic radius gradually. Number of proton increases. Number of proton in the nucleus increases means radii will be decreasing, student. So radii decreases. So question number 80, option number 2 will be correct, student. Question number 80, option will be 2 is correct. Next, the lengthenoid contraction is responsible for the fact that, okay, zirconium and hafnium have almost same radii. Because of lengthenoid contraction, student, shielding effect is very less, so that is size become very equal. So zirconium, hafnium have the almost same radii. Correct option is the option number 1. I am not reading other options, student. They are all are irrelevant. Question number 82, student. Consider the isoelectronic species Na plus, Mg2 plus, F1. The correct order of increasing order of radii. Increasing order of radii means negative charge. Negative charge means what? Negative charge, more radii. Okay, more radii. So you check out, student, which is having what radii. So negative charge, which is O2 minus, is there. So largest radii O2 minus. So this is all wrong. So correct option is directly you can write option number 2, student. 82 will be option number 2. Now let us move for 83. The atomic radii in case of inert gases is van der Waals radii. Inert gases, there is van der Waals radii, not any covalent, ionic or any other radii. Which of the following set of element is arranged in the order of increasing atomic radii? So that is top to bottom, student, top to bottom radii. What is happening, student? Radii increases. Okay, now you see, student, sodium, magnesium, it is decreasing order, student. They are asking increasing. So left to right decreases. So this is wrong. Carbon, nitrogen, again left to right wrong. Iodine, bromine, this is also wrong. Osmium, sulfur, selenium. So oxygen, sulfur, selenium, tellurium. So this is top to bottom. If you are going, radii increases, student. Radii increases. So correct option will be option number 3, student. Next question, let us move, student. Next question, what is there, student? 85. Which of the following combination contain only isoelectronic ions? Which of the following combinations containing only isoelectronic ions? So isoelectronic means same number of electrons. So how many, if you are going 85, so we have to check that is which is having the same number of electron. So student, if you see phosphorus, 15 minus 3, that is 15, and 3 electron, that is it is 18. Sulfur is also 18, chlorine is 18, and this is also 18. They are isoelectronic. If you are considering other, nitrogen is 10, fluorine is 10, oxygen is 10, argon is argon, if you are talking a student, no, it is 18, so this is wrong. If you are this one student, if it 10, this is the 18, 18 and 18, this is also wrong. Nitrogen is 10, this is 10, that is 18 and 10, so this is all wrong. So correct option is option number 3. Ionic radii vary, they are asking one question student, you see 86. Ionic radii vary in, okay, how it vary ionic radii? Okay, so ionic radii, when you are talking about student, inversely proportional to effective nuclear charge, inversely proportional to the effective nuclear charge. This is the correct option student. Uh, Radii is equal to 1 by what is Z effective. So greater the Z effective, smaller radii student. So correct option is option number 1 student. Thank you so much for watching friends.